There are a few things you need to understand before you can start to think about balancing equations. The small numbers at the bottom tell you how many atoms there are. So in CaCl2 we have 1 calcium atom and 2 chlorine atoms. You can't change these numbers because if you do, you're changing the actual molecule itself. CaCl3 is a completely different thing to CaCl2. These little numbers only refer to the element that is immediately before it. So this means 2 Cl, but only 1 calcium. The big numbers at the front of the formula refer to the whole molecule. They tell you how many there are. So 2H2O says that there are actually 2 water molecules. This means that in total we have 4 hydrogens and 2 oxygens. You can change the big numbers in front of the molecule because all you're doing is changing the number of molecules that there are. You're not changing the actual makeup of the molecule. You should always go through the same steps when balancing equations. First, you need to count the atoms. In this case, we have 2 hydrogen atoms on the left-hand side and 1 hydrogen atom on the right-hand side. We have 2 chlorines on the right and 1 chlorine on the left. Because there are different numbers of atoms on the left-hand side to the right-hand side of the equation, it is unbalanced. Once you've worked out that the equation isn't balanced, you need to add numbers to try and balance it. Always start with 2's. Remember, you cannot add numbers, small ones at the bottom here. You can only add them at the front to change the number of molecules. In this case, I'm going to try adding a 2 to the HCl on the right-hand side. Then you need to recount the atoms on each side. Remember, this 2 refers to the whole atom of hydrogen chloride. So now, on the right-hand side, instead of 1 hydrogen atom, we have 2, and instead of 1 chlorine atom, we also have 2. Then you need to check if it's balanced. In this case, we have 2 hydrogen atoms on the left-hand side, 2 hydrogen atoms on the right, 2 chlorines on the left, and 2 chlorines on the right. So, yes, it's balanced. If it wasn't balanced, you just repeat steps 2 and 3 until it is. Right, let's have another go at an example. First, count the atoms. For iron, we've got 2 on this side, 1 on this side. Oxygen, 3 on this side, 3 on this side. Aluminium, on the left-hand side we've got 1, but on the right-hand side 2. So we know at the moment it isn't balanced. Right, first of all I'm going to try and balance the iron atoms. Remember, you cannot put a little 2 at the bottom of the iron. This would change the actual molecule and you can't do that. You can only put one big 2 in front of the iron on this side. Then you need to recount the atoms. Nothing's changed on the left-hand side, but the right-hand side, instead of having 1 iron atom, we now have 2. The equation is still not balanced because we still only have 1 aluminium on the left-hand side, but we have 2 on the right. So you need to do something to change how many aluminiums there are on the left. Remember, always start by putting 2's in front of the molecules. I'm going to put a 2 in front of the aluminium and recount the atoms again. Now we have the same number of every atom on the left-hand side and the right-hand side of the equation, so it's balanced. Fe2O3 plus 2Al goes to 2Fe and Al2O3. One more example to work through. Again, step 1, count the atoms. On the left-hand side, we've got 1 calcium, 2 chlorines, 1 potassium, 1 oxygen, and 1 hydrogen. The only thing you need to watch out for here is the brackets. The brackets show that this little 2 refers to everything within that bracket, just like in maths. So, on the right-hand side, we've got 1 calcium, 1 chlorine, 1 potassium, but 2 hydrogens and 2 oxygens. Remember those black brackets. At the moment, the calcium and potassium are balanced, but the chlorine, oxygen, and hydrogen are not. There's 2 chlorine on the left-hand side and only 1 on the right. So I'm going to add a 2 in front of there here to say that there's now 2 molecules of KCl. Then I can recount. We've still got 2 calciums on the left-hand side, but on the right we now have 2 calciums as well. Putting the 2 in front of KCl has also changed the number of potassiums. We now have 2 on the right-hand side. We can see that the equation is still not balanced. We still only have 1 potassium, 1 oxygen and 1 hydrogen on the left-hand side, but 2 of each of those on the right-hand side. So we need to try something else. I'm going to put a 2 in front of the potassium hydroxide on the left-hand side and then recount. Have a look at what happens. You can see we have the same number of all the different atoms on each side of the equation, so it is now balanced. CaCl2 plus 2KOH goes to CaOH2 and 2KCl.